All right, in this video, we're going to look at logarithmic functions, and specifically, we're going to look at how to convert between exponential and logarithmic forms of equations, and that's going to help us evaluate things. So you saw this last year in advanced algebra. So just as a quick recap to get your mind going, kind of refresh maybe what you learned in the past, we're going to be looking at how to go from the log form of something that looks like this and convert it to exponential form, which would be 4 to the second power is equal to 16. These two statements are equivalent. This is log form over here. This is exponential form. And we'll just review how we can go from log form to exponential form and vice versa, and then look at things that we can do once we have converted them. But that's where we're headed in this video. So we'll recap how to do all of that. But before we do that, I want to look at some helpful negative and fraction exponent properties that we're going to be able to, or that we're going to need to be able to deal with to work with some of these problems. So first of all, with negative exponents, we talked about this on Tuesday. And remember, we looked at some patterns, but what we found out or reviewed from the past is that if you have a negative exponent, you are going to take the reciprocal of the base and then take that to the positive exponent. So 4 to the negative 2 just becomes 1 over 4 to the positive 2, which is 1 over 16. And then you can also start with a fraction and take that to a negative exponent. I'm still going to use that idea that I'm going to take the reciprocal of this one, so 1/5, I'm going to change that to 5 over 1, or you could just use 5, obviously, and then I'm going to take that to the positive power of 3, and then I'm going to get 125. So those are things that are going to pop up. And then a couple of things with fraction exponents that are going to be really helpful moving forward, and you may or may not know this already. But when you take the square root of a number, that's the same as taking that number to the exponent of a half. So this is just a definition. The square root of 16 is the same as 16 to the 1/2 power. And your calculator will tell you that as well. Okay, so that's going to be helpful. And then another kind of, I don't want to say trick, but something that we're going to want to be mindful of is we can use this idea of taking something to the half when we have multiples of that. So if we have 81 to the 4th, what I can do is I can rewrite that as 81 to the 1/2 and then all of that to the 1/2. Okay, because when you take a power to a power, you multiply those two fractions. So a half times a half is a fourth. These are equivalent. And then I can say, well, 81 to the 1/2, that is 9 because I'm taking the square root. And then 9 to a half, the second 1/2 power, is the square root of 9, which is 3. So we're just taking the square root twice if we're raising it to the 1/4 power. Okay, so these things are going to pop up, and we need to be able to work with these properties moving forward. All right, so I would say taking notes through this video would be a good idea, maybe pausing it, but you do what you need to do to be successful with this content. Okay, so this is a review from last year. We had a unit on logs, and essentially a logarithm is a question about an exponent. And this is just a definition. The log form looks like this. Log base b of a is equal to c. That's how we say it. Log base b of a is equal to c is equivalent to a being equal to b to the power of c. Okay? So essentially this part, underlined in red here, is really the exponent you raise b to get a. Okay, the exponent you raise b to get a. That sounds kind of, I don't know, it just kind of sounds awkward. We just need to be able to go between these two forms. Some people memorize it. Some people notice that the b and the c here are separated, but they're not separated here. But I have found a really effective way to like it's almost like muscle memory when rewriting these for me, is I start with this log form, and then if I draw in these two arrows, this to this is equal to this, so that I can write B to the C is equal to A. And again, it's just something about drawing those arrows that helps me convert from this form to this form. So that's usually what I'll do. Okay, so that's just something we have to get fluid at. We have to be able to do that to solve these problems. Just takes a little bit of practice, and pretty soon you'll have that memorized, and maybe you already do from last year. Okay, so the first thing we're going to do is practice going between the log and exponential form. So here I have log base 4 of 16. Okay, this is going to be equal to some number, and I'll worry about that in a moment, but here's what I'm thinking about. If I change this to exponential form, 4 to the something is equal to 16, right? So I can rewrite that over here. 4 to the something, I'm just going to call it x, is equal to 16. Well, I know 4 to the second is equal to 16, right? So that means log base 4 of 16 is equal to 2. This to this is equal to this. So here's the log form. Like all of this, log base 4 of 16 is equal to 2 is the log form. And then 4 to the second is equal to 16 is the exponential form. So right now we're just worried about going between the two forms. Okay, let's look at another one. So here I have exponential form, 4 to the negative 2. Well, first of all, I need to figure out what this is. So using that idea of negative exponents, I know that this is the same as 1 over 4 to the positive 2, which is 1 over 16. So exponential form, 4 to the negative 2 is equal to 1 over 16. I need to write that in log form. So log base 4 of 1 over 16 is equal to negative 2. The exponent is always what it's equal to. And then what I like to do with those arrows that I was talking about is just double check. This 4 to the negative 2 is equal to this, which is what I had. 4 to the negative 2 is equal to 1 over 16. So first I had to figure out what that actually was to write it in exponential form, and then I can convert it to log form. I have this up here, like I'll have these on the slide so that if you need to pause and just think about like the A, the B, and the C value, you can do that. Okay, so just to recap, here's the two examples that we looked at. This is log form, exponential form. Log form, exponential form. They're equivalent. It's just definitions of writing the relationship that 4 to the second power is equal to 16, or 4 to the negative second power is equal to 1 over 16. All right, we're going to do some more conversions. So at this point, if you are feeling like, hey, I think I want to try this, pause the video and then press play and you can check your work. Okay, so I'm starting with the exponential form, 9 to the 1/2 power. First of all, I need to remember that the 1/2 power is the same as taking the square root. So 9 to the 1/2 power is 3, the square root of 9. So now I have my exponential form, and I'm going to rewrite it in log form. So log, I take my base, which is 9, of 3 is equal to 1/2. This to this is equal to this. Now I kind of glossed over this, but we don't want to forget that in log form, that base is a subscript. So that needs to be clear when you're writing it. 9 to the 1/2 is equal to 3. Okay? If you start in log form, we can go to exponential form. Now this one's missing a number. We're going to figure out what that is. So the first thing I'm going to do is fill in what I know. 81 to the negative 1/4 is equal to something. So 81 to the negative 1/4 is equal to something. I got to figure out what that is. Now this one is actually like we got to think through what this is going to be. And at this point, we're evaluating these without calculators to just get used to thinking about these problems. So what I'm going to do is I'm going to use that idea that I can break this up into 81 to the 1/2 and then to the -1/2. Because these two multiplied together give me -1/4. So I can rewrite that as an equivalent expression. And now I'm going to use the idea that 81 to the 1/2 just means taking the square root of 81, which is 9. Now I need to take 9 to the -1/2. Well, I know that a negative exponent means I can write it as 1 over 9 to the +1/2. Okay, so let's just recap. I think I went kind of fast through that. First thing, instead of to the -1/4, let's break it up into a half times the -1/2 because I know how to deal with something to the 1/2. It's just taking the square root. So I'm going to do 81 to the 1/2. That's 9. Then I'm going to take 9 to the -1/2. Well, I'm going to deal with the fact that this is a negative exponent. So by definition, that's 1 over 9 to the +1/2. Well, 9 to the 1/2 is the square root of 9. We did that one up here, so this is all 1/3. So I'm going to go back to the original. 81 to the -1/4 is 1/3. Therefore, I can finish filling this log form in that log base 81 of 1/3 is equal to -1/4. This to this is equal to this. So here I have my exponential form, and here I have my log form. Okay, that one's complicated just because there's a lot going on with exponent properties and breaking it down. Let's look at a couple more. Actually, we're going to move on to evaluating, which is also going to involve rewriting. So at this point, like I said, we're going to evaluate without calculators to help us think more flexibly about the relationship between these forms. And I encourage you to pause the video to try them and then check your own work. All right, so here I have log base 5 of 625. I want to know what that's equal to. So what I'm going to do to help me think through this is I'm going to rewrite it in exponential form. 5 to the something is equal to this. Remember, b to the c is equal to a. So I'm just going to write 5 to the something is equal to 625. Well, I am going to just start multiplying 5s to see where I get. 5 times 5 is 25. Times 5 more is 125. Times 5 more is 625. So 5 to the 1, 2, 3, 4. 5 to the 4th is equal to 625. Therefore, log base 5 of 625 is equal to 4. This to this is equal to this. Right? Those arrows really help me, but this is my answer. It's like a sentence. Log base 5 of 625 equals 4. We're just going to keep going. We're going to do a few more to just kind of build some, just get more familiar with this, I guess is what I want to say. Okay, so here we have log base 4 of 1/64. I want that to equal, I want to know what that equals. So I'm going to change it to exponential form. 4 to something is equal to this, right? So 4 to some power is equal to 1 over 64. What do I know about fractions with exponents? I know I need a negative exponent. So what I'm going to do is just think about it this way. I know that 4 to the third is 64. 4 times 4 is 16. 16 times 4 is 64. So if 4 to the third is 64, to get 1 over 64, I need to make this negative. So 4 to the -3 is equal to 1 over 64. So log base 4 of 1 over 64 is equal to -3. This to this is equal to that. Okay, log of 100. If you do not see a base, do you remember from last year what that meant? This is known as the common log. Common because it uses a base of 10. And obviously that's common in our number system because we have a base 10 number system. So if it helps you, you could rewrite this with a little 10. You're not going to see that in a problem, but you could definitely write that in. So 10 to the something is equal to 100. Well, 10 to the something is equal to 100. We probably already think of what that is. 10 to the second is equal to 100. So therefore, this is equal to 2. Log of 100 is equal to 2. Okay, here we have another common log. So we have log of 0.1. We haven't done really anything with decimals, so I would rewrite this as a fraction, 1/10. I know that 0.1 is 1/10. Okay, so this to something is equal to this. Well, the base we don't see here, it's the common log, is 10. So 10 to something is equal to 1/10. Again, it's a fraction, so I know it's going to be a negative exponent. And I don't need to raise 10 to any power, so it's going to be 10 to the negative 1 is equal to 1/10. Because that'd be 10, like you take 10 to the first power in the denominator. So this is just equal to negative 1. 1/10 to the negative 1. I lied. I just misspoke. This is a base of 10. We don't see. 10 to the negative 1 is equal to 1/10. Okay, let's try a couple more. You might remember this from last year. This ln stands for the natural log, and it's another one that occurs pretty often. Things that are compounded continuously. It could be money, it could be bacteria growth. A lot of things compound continuously, and E is a number, like an irrational number like pi, and it's 2.71, I think. I feel like I should know that. E to the 1. Yeah, 2.718, I guess I was a little bit off. So that's an irrational number. So it just occurs a lot, so you'll see that. So if you see this, it means we're talking about a base of E. Well, so then this one is kind of strange because what it means is this base of E to some power is equal to this thing. So I'm going to write that and then see what we have. E to something is equal to E to the 8th, which sort of seems odd, but here's what, like, the base is E, just we don't see that. It's like the common log had a base of 10. It's not written in. And then, so that's going here. And then the something that we're trying to figure out is this, is this part. And I wrote it as an X here. And then this E to the 8 is, like that's what my answer is going to equal. That's here, and that's here. So E to the something is equal to E to the 8th. Well, once you have that written, it looks obvious. I mean, if E to the X is equal to E to the 8th, then X has to be 8, right? So this one, as weird as that was, the natural log of E to the 8 is 8. E, which we don't see again, to the 8th is equal to that. It's some number, but we're not figuring out the decimal approximation. Okay, so you'll see some like that. Just rewriting really helps. Okay, let's look at this one. We have log base 8 of 512. So 8 to the something is equal to 512. So 8 to the something is equal to 512. So now I need to multiply 8s to see what's going on. 8 times 8 is 64. 64 times 8 is 512. So it's 8 to the third is equal to 512. So then over here we have log base 8 of 512 is equal to 3. This to this is equal to that. Okay, log base 4 of 1. So what we have is 4 to the something is equal to 1, right? 4 to the something equals 1. Well, we know to get a 1 with an exponent, that has to be an exponent of 0. So 4 to the power of 0 is equal to 1. So this one just equals 0. 4 to the 0 equals 1. Okay, you might see some where it asks you to estimate the value between two numbers. So that just means, it's not an exact answer. So we have 2 to the something is equal to 20. So 2 to the something is equal to 20. And then I'm just going to, I know that 2 to the third is 8. Not enough. 2 to the fourth is 16. 2 to the fifth is 32. So if I'm looking for a power that gives me 20, it must be between 4 and 5. So the way you would answer this question, estimate the value between two numbers, log base 2 of 20 is between 4 and 5. And we're not going to get any more specific at this point what that value would be. Okay, here we have 16 to the something is equal to 4. Okay, so 16 to some power is equal to 4. Well, it got smaller, so I'm not going to take, a big exponent. It's not a fraction, so it's not a negative exponent. But I do remember that if you take something to the 1/2 power, it's the square root. And I recognize that 4 is the square root of 16. So it must be 16 to the 1, or it is 16 to the 1/2 power is equal to 4. So 16 to the 1/2 power is equal to 4. In log form, log base 16 of 4 is equal to 1/2. Okay, couple more. Actually, this is the last one. So again, just going to set it up. 7 to something is equal to 1/49. So 7 to some power is equal to 1/49. Couple of things that are jumping out. 7 to the second is 49, but I have a fraction 1/49, which means a negative exponent. So that must mean that 7 to the negative 2 would be equal to 1/49, because this is 7 to the positive 2. But I want it in the denominator of the fraction. So 7 to the negative 2 is 1/49. Sometimes after I do these, I look at the log form and then set it up and make sure that it's correct. So this to this has to be that. So I just double check it. 7 to the negative 2. Well, I know that that's 1/7 to the positive 2, which is 1/49. And boom, that's what I wanted. Okay, at this point, I know that was a lot, so it might be worth it to go back through a couple of those. But at this point, based on that information, those examples, you should be able to look at page 3 in your homework packet and complete problems 1 through 3.